Okay, so for today's lesson, you will be writing expressions using real-world formulas. For example, you'll be looking at the volume and the area formulas of a cube, and you will be looking at perimeter and area today. So again, in your objective, please write down that I will be able to use write expressions, and evaluate expressions using real-world formulas. Do that now. For your do now, you are going to be deciding on which of the following expressions are equivalent and why. And if an expression has no match, you're going to write an equivalent expression to match it. So just to clarify, you're going to be looking at kind of simplifying these expressions. Some are using distributive properties, some are just have to use the distributive property and find like terms. If you cannot find a match, then you're going to have to come up with your own equivalent expression to it. So go ahead and try that now, and we'll go over the answer shortly. Okay, when you go ahead and look at these expressions, and I use the distributive property here because that's what I'm seeing. I see x plus 4. I need 2 of those, so it becomes 2x plus 8. So if I look at this one and this one, this is just the commutative property because it's just flipped around, so A and B are a match. When I come down here, 2x plus 4 does not match that. So if I wanted to write an equivalent expression for that, I see that 2 and 4 have a common factor of 2. I can pull that out. What's left over within the parentheses would be x plus 2. And this would be the same as this expression here. Again, I saw a common factor of 2, so I pulled that out. And then what remains is x plus 2, because there's your 2x plus 4. In this case, when I simplify this, it becomes 3x plus 12 minus 4 plus x. So I'm going to go ahead and combine like terms. I've got 12 minus 4 is 8. So I have 3x plus 8 plus x. So this becomes 4x plus 8. So this is the same as 4x plus 8, which doesn't match anything. So then I see a common factor of 4. I can rewrite it as pulling out a 4, x plus 2. So here again, we don't have a match because this was pulling out a factor of 2. This is pulling out a factor of 4, so that's not a match. And then I don't see a match for x plus 4, but I can rewrite this by pulling out a common factor of 1 and rewriting it using the distributive property, which would mean the same thing. Okay, there's several problems here, and you're going to be given anywhere from about 10 to 15 minutes per problem. You're going to take a look at the problem. You're going to use the formula given, and then you're going to write an expression and then, of course, apply the formula, which is part of the Common Core. So we're going to be using perimeter of a rectangle, and it says to compute the perimeter of a rectangle, you add the length L and the width W and double the sum. So you're going to have to find some keywords in there. Then you're going to first write the expression for the perimeter of a rectangle. I challenge you to write more than one. And for part B, you're going to use the expression then to find the perimeter of a rectangle with length 10 and width 15. So you're going to go ahead and work on that independently, and then we'll check the solution. Okay, in this problem, I see that there are a couple of keywords here. I see the word add, and I see the word double. So that means something to me. So when I write the expression, if I'm taking my length, I'm adding my length plus my width, and that becomes a sum, and then I have to double my sum. I'm going to put that in parentheses because I have to do that first, and then times 2. This would be one way to write it. If you don't have that, go ahead and write that in your notes. Next, I could write it as L plus W plus W, which means the same thing because I'm doubling the sums, so I've made 2 of each. Or I could have written it 2L plus 2W. Any one of those would work fine. So then I'm going to use the expression to find the perimeter of a rectangle with length of 10 and width of 15. I'm going to go ahead and use this one right here first. So I'm going to substitute in 2 times 10 plus 15, just like we learned to do in hands-on equation. We substitute in for the variables. And I'm going to do what's in parentheses first. 10 plus 15 makes 25. And I'm going to keep it in parentheses because I still got to multiply it by 2, which makes 50 units. And that's my final answer. This problem says the students in Mr. Smith's class are writing expressions for the perimeter of a rectangle of side length L and width W. After they share their answers, the following expressions are on the board. Ryan says 2 times the quantity, L plus W. Brittany says L plus W plus L plus W. Christina says 2 L's plus W. And Paul says 2L plus 2W. You're to answer 2 questions. Which of the expressions are correct? And B, how might the students have been thinking about finding the perimeter of a rectangle? So that's going to require you to do some writing. Go ahead and try and solve that now. Okay, for part A, which of the expressions are correct? Each of the expressions is correct except for Christina's. Christina forgot to put in the second width. So how might the students have been thinking about finding the perimeter of a rectangle? Ryan is looking at finding the sum because perimeter means to add up all the sides. Ryan's looking at taking the sum and then doubling the sum. Whereas Brittany is going back to kind of what you would do just initially. You take all the side lengths, the length plus the width plus the length plus the width. You go all around the side and add it up. And then Paul kind of simplified it by saying, well, there's 2 widths and there's 2 lengths, so I'm going to take the width and the length and I'm going to multiply each one of them by 2. Some of the students at Herrick Middle School like to ride their bikes to and from school. They always ride unless it rains. Let D be the distance in miles from a student's home to the school. Write 2 different expressions that represent how far a student travels by bike in a 4-week period if there was 1 rainy day each week. So you're going to go ahead and start writing this expression. Try to at least get 1 expression that represents the distance from the student's home to the school. And after that, if you can try and get another one, that would be great. You'll be given about 10 to 15 minutes to solve this problem. Okay, so this one is a little bit more challenging to set up, I'm sure. So hopefully you at least got 1 expression. One of the things that you have to keep in mind is the essence of the problem. It says it's the Herrick Middle School, so they're writing to and from school. That's important, and they always ride unless it rains. So school is only 5 days out of the week. So to simply write this, you would have you would have to write an expression something like this. On 1 day, it's the distance there plus the distance back. And then I would add to that the distance there plus the distance back. So that would be the second day. Plus the distance there plus the distance back. And then I do it again for up to 5 days. Okay, that's the first part of the problem. So we have 1, 2, 3, 4, plus another distance there, distance back. So that would be 5 days worth. So when I look at all of these, I have 1D, 2D, 3D, 4D, 5D, 6D, 7D, 8D, 90, 10Ds. Okay, except for the fact that they said that 1 day each week they don't go. So I can actually take away 2Ds. Okay, so in 1 week, they travel a distance of 8D. But what we have to do is we have to make sure that we understand that it is for a 4-week period. So we have to do 4 times the 8D, which is 32 Ds. So as you can see, I wrote an expression out as D plus D all the way out, which is the same as 10D minus 2D equals 8D. And then I wrote it again as 4 times 8D. So there could be many ways you could write it. You could also have written it at this point in time. If you saw this, you could do 4 times 10D minus 2D. And you could distribute, which becomes 40D minus 8D. Which again is 32D. Lots of different ways to write it. If you have something different, check with the teacher, see how it goes, see if you did it correctly. To find the Okay, we're going to take a look at the volume of a cube, and you are going to write the expression that we have right now is length times width times height. We've learned that in science class. So we're going to write this expression another way. Part B says that the side length of the cube is 2. What is the volume? And the volume, what is the volume if the length is 4? And we want to prove that both expressions work. So in part B, we can kind of do part C because we can try both to see how they work. So before you begin, I want you to think about a cube and what's important to a cube and see if you can come up with a different expression and then try out your theory. You'll get a couple minutes to do this. So when I look at a cube and I think about a cube, I know that a cube has all the sides the same. So if I was going to write this, I might be looking at taking the side times the side times the side, and I can call them all the same letter because they're all the same thing. So repeated multiplication becomes an exponent. So it's side cubed. So volume equals side cubed, and we just proved that. Here's actually 2 more ways of writing it. So let's check it out. So if I have a cube that's 2, in my expression of length times width times height, I'm going to do 2 times 2 times 2, which is 8 units cubed. And in my formula of volume equals the side cubed, I need to know what 2 cubed is. Well, 2 cubed is equal to 2 times 2 times 2. So that also equals 8 units cubed. So we proved that both formulas worked. So let's try it with 4. In 4, we have 4 times 4 times 4, which is equal to 64 units cubed. And if I want to know what 4 cubed equals, because I'm plugging it in my other formula, it's equal to 4 times 4 times 4, which again is 64 units cubed. So by showing my work, I'm able to prove that both expressions work. Okay, so now we're going to be looking at the surface area of the cube, and we've already been given the formula or the expression, same thing, as 6 times the side squared. So I'm going to caution you on this one because a lot of times you want to do 6 times s and then square the whole thing, and that's not how this works. You would have to square the side first, then multiply by 6. That's your orders of operations in effect. You have to do the exponent before you do the multiplication. So you're going to be looking at the surface area of a cube with a side length of 1/4. You're going to look at the surface area of a cube with a side length of 0.5 and a surface area of a cube with a side length of 1.6. And just so we're clear, surface area is the outside of a 3-dimensional figure. It's like if you were wrapping a gift. That would be finding the surface area. So go ahead and do that now. This is a great review of decimals and fractions. Okay, so for my first problem, we're going to go ahead and take a look at plugging into my formula. So I'm going to have 6 times, I'm going to put parentheses around 1/4 squared. So what's going to happen is I need to find out what 1/4 times 1/4 is. And remember, and when we multiply fractions, we multiply numerators, multiply denominators. So it becomes 1/16. And then I have to multiply it by 6, and I can put 6 on the end because it is multiplication is commutative. If I put a 6 here, I have to make it into a fraction by putting it over 1. So it becomes 6/16. When I look at this, the numerator and the denominator both have a common factor of 2, so I'm going to divide that out because I have to simplify it. 6 divided by 2 is 3. 16 divided by 2 is 8. So my surface area is 3/8 units squared. In this case, for 0.5, it's going to be 6 times 0.5 squared. That's how I would substitute it in. I have to find 0.5 times 0.5. So that makes 5 times 5 is 25. 2 decimal places makes it 0.25. So I'll have to do 6 times 0.25. Notice how I just did that in my head. I didn't have to write it out. Remember, multiplication, just like normal, except we count decimal places. So in this case, it looks like 25 cents. If I have 6 of those, how much money do I have? Again, using my mental math skills, that would be $1.50. So it would be 1.50 units squared. And in the last problem, we do the same thing. We take 6 times 1.6 squared. So I have to do 1.6 times 1.6. For those of you using a multiplication chart, you can do 16 times 16. I'll go ahead and do it out the long way so you have it for your notes. 6 times 6 is 36. Carry the 3. 6 times 1 is 6 plus 3 is 9. And I do it again. This time, though, I got to put a 0 here because I already used that place value. 1 times 6 is 6. 1 times 1 is 1. And I go ahead and add them up. 6, 5, carry the 1, 256. But I know it was 1 6/10, so I have 2 decimal places in my problem, 2 decimal places in my answer. So now I have to take 2.56 and multiply it by 6. So that's 36, carry the 3, 30, 33, carry the 3, 12, and 15. And how many decimal places do I have in my problem? I have 2. So I have 2 in my answer. So my answer is 15 and 36/100 units squared. Please make sure you write this in your notes if you didn't have it done correctly.